All right, as promised, here we are. We're back, and we're going to continue battling through the Neetcode map. So let's keep on going. Let me make myself a little bit smaller, and let's go. So lowest common ancestor of a binary search tree. Okay. Here we go. Given a binary search tree where all node values are unique, okay, and two nodes from the tree P and Q, return the lowest common ancestor of the two nodes. Okay, the lowest common ancestor between node P and Q is the lowest node in a tree T, such that both P and Q are descendants. The ancestor is allowed to be a descendant of itself, okay? So output is 5, output is 3. All right, explanation. The lowest common ancestor of node 3 is of node 3 and 4 is 3, since a node can be a descendant of itself. Output is 5. Hold on, let me try to read this again. Of two nodes in the tree, P and Q, okay? Return the lowest common ancestor of... Oh, so we're given P and we're given Q. Is that correct? Yeah, we're given... Okay. So 3 and 8. Okay, is this one here. And then if there was more stuff up here, we would still return 5, I believe. So now this one, 3 and 4 here. I say 3 because 3 is an ancestor of itself, so that means that it is... This 3 contains all children of both itself and Q. Okay, so I'm gonna come here. And I am going to recurse down until, let's see, so I find P right here, but I still need to recurse down, and I come here, I still find 3, okay? And so I'm thinking I'm returning some Boolean variable up. So I'm gonna say, come here, and then I might say like P true, Q false or something. And then I find this 4, and now both of them are... Wait, no. Come here, I find this 8. Both of them are true. No, I'm going to have my left and my right, and both of them can say independently if they are a child of that P or Q. So I should be able to do something like this. So def traverse and then node, okay? And then if not node return false, false, something like this, okay? And then I am going to say if, and notice that the value of P and the value of Q, okay, so both of these are tree nodes, so I can do if node is equal to P, okay, then P found is true. Okay. If node is equal to Q, Q found is equal to true. Okay. And then so that's the current node. I'm checking the current node, and then I want to check. Maybe what I can do here is Q equals is P equals false, like this, and now change it to be is Q is P. Well, this one is, I really don't like this. P, I hate P and Q because they're the exact same letter, just I'm just gonna go Q. Oh wait, this one is Q and this one is P right there, and then I'm changing that. So P equals P, Q equals Q. Okay. Okay. So now is this one is P is P and I want to check if it's a descendant. So maybe I say like traverse node dot left traverse node dot right left P left Q is equal to here, and then right P right Q is equal to this. Okay. So now I want to say answer is equal to none. Then do I need the non-local answer? That. Now, I will say if not answer and I'll say both found is equal to and this, so I need the right, or sorry, I need P, so I need to find both P and Q. So that means right P or left P, right? Because either one, if it's an ancestor of either the left or the right, and we also need Q, so right Q or right, or sorry, left Q, okay? So if we have not found the answer yet, and both found, then we want to update answer. So answer equals to the current node that we're on. Now we want to return P first, okay? So we want to return P first here. Copy this. And we want to also return Q second, right? So now what I should be able to do is traverse node like this, return answer like this, and now I might need to make non-local for P and Q. We'll see about that. We'll see if we get an error. Yeah. Name P is not defined. Do you mean P? No, I want to declare a new variable. Oh, I see what's up. I see what's up. There we go. Let's see if we need that non-local. Wrong answer. Node is not defined. That would, we need the root in there. Okay, come on. So if it's none, name right Q is not defined. All right, come on. Let's get rid of all these silly little mistakes. Is it possible that both P and Q will exist? So why would it not hit this? If one of these for the P is found and the Q is found, okay, P, P, Q, Q, right, left, okay, and I keep passing that up, left and right. Oh, I need to incorporate if I am P or Q. So, or is P or is Q, okay? Let me do this. Now, or is P or is Q. Should be like this. Wait for us. Come on, come on, come on. No. If it's equal to Q. Okay. Well, that is a ChatGPT. What's going on? Okay. You're returning two booleans, but you're splitting them into left and right like this. Yep. Then you compute this. Not always the case. For example, one of them could be the current node, and the other one could be either a subtree. Either subtree. Instead of tracking P and Q separately, just track whether either is found in the current subtree. Then if 2 out of 3 flags are true, you've found it. Middle, left and right, okay. Answer equals node. But why is mine wrong? What line do I need to change? I really hate all the bouncing that it likes to do whenever it's creating new content. Okay, is this one both found? It assumes P and Q must be found in separate branches. Why does it assume that? If it's like this, I come in here and I say that, hey, I am Q. So is Q. All of this is going to be false. And then I'm going to return is Q up here. So then I have I have right Q here. And then so this one is true. And I'm on 3. And I also noticed that I am P. So I have right Q and is P. So now I come in here, both found. So is P was found and right Q was found. Therefore, both are found. Answer was not found. Both found. Change answer to node. There, done. Okay. No, I want to know why mine is wrong. That's ridiculous. What's going on? Don't tell me this. I don't want to hear this. Can you show me an exact example of why mine will fail? Then it'll do its bouncing. Watch this. Ooh. And then, oh, it's not doing the really big bouncing. Anyways. So 5 and 4. Okay. Four is true, P is false. Is Q, so I'm at Q here, 4. So that's true. But now imagine the case where LCA is 2 because 7 and 4 are both children of 2. 7 and 4. 7 and 4, so 2. Okay. At node 7, it returns true and false. So true and false, yeah. 4 returns false and true. Yeah. At node 2, left returns true, false, right returns false, true. Is Q equals false? Yeah? So now we go true, or, so this evaluates to true, and false, or, so true, this evaluates to true, so it comes out to be true, yes. Well, where are you? Well, okay. I don't care about the, here. 2 and 4. Because 2 isn't, where's 2 and 4? 2 and 4 here. So at node 2, is P is true. Okay, yeah. Is Q is false, yeah. Left returns false, false from node 7. Right returns false, true from node 4. And we get the right answer. You just said there was a failure case. Okay, where is the actual failure case? But now I'm at, oh my goodness, failure case, you got it correct. Okay, now after the 20th time, fails to detect, okay, here we go. P is 7, Q is 7. Is that even possible? Because it says, oh, it just says that they both exist. Okay, fine, whatever. So now, is P is true, is Q is false. Why is Q false? Because you're checking node equals P. Is P is Q. This would be true and this would be true. Evaluating to true sets this to be true, true answer. Okay, so because you're checking node equals to Q and node equals to P separately. So they just get updated. What's the problem? So both found it, no, no, it's actually not. They're two separate. Oh, is this some ridiculous thing where I need to do is P? I thought it instantiated two variables and it just assigned. Let's see. Okay, well, I don't see what's wrong with this, honestly. And ChatGPT can't come up with why it's wrong either. Obviously, I'm getting it wrong. What do the solutions say? Okay, I can't. I don't know. I'm not sure why this should be right. I think it's right. I don't know. Lowest common ancestor. Max of the P and Q value. If not root and not P and not Q, return none. Or not P or not Q. Okay. If the maximum value is greater than the root value? Well, why do we care? Is it like ordered? Is the tree ordered? Okay, so it's a binary search tree? Oh, okay, I guess it is. But that doesn't affect my solution. And it still is, I don't know. It says that it's wrong for both cases. Okay, fine. Move on to the next one. That one's ridiculous. I don't want to do binary trees. Do we do linked lists? Maybe, I don't know. Reverse a linked list, fine. Given the beginning of a singly linked list, head, reverse the linked list and return the new beginning of the list. Okay, whatever, I don't know, man. So I just need to flip them around, right? We'll see. Well, node dot next. Okay. Node equals to head and I don't know. Temp is equal to node dot next, and then I do node dot next is equal to do I need the previous? Previous or something? I don't know. Equals none. Okay. Set it equal to previous. Then what do I do? Oh, man. No, or previous equals node. Okay. And then node equals temp. Okay. Return node. Is it something like this? I don't know. No, okay, fine, whatever. What do I want to do? I'm gonna have to draw this out or something. I don't know. I have my nodes here. There we go. Goes like this, goes like this, goes like this, goes like this. And then goes to ground. Okay, so head is here. Head is there. I want to come here, and this one is going to be now equal to none. Does that make sense? And then I want to say this one's next is equal to here. So I say that this one's temp. Okay, so I grab a hold of it. So I want to say temps. It's node.next. Okay, whatever. The previous should be correct. So previous. I want to say previous.next. No, I don't want to do that. I just want to change this one to be like up in the clouds. I don't know. And then I can come to here, and then I change this one, right? It's equal to there, because that's already previous. Next node. Next node. Node.next equal to the previous one. Okay, that makes sense. Now, I say that the previous node is now equal to my current node. Okay. That makes sense as well. Then I come here and I assign the current node that I'm at is equal to my next node. Okay. So well, head is 0. I feel like I'm in topsy-turvy land today. While node.next, okay? Then what we do is we do node equals node.next, okay? Then we return. I just want to see it. Does this throw an error? Okay, so that doesn't throw an error apparently. Yeah, that's what we expect. Well, this isn't very good. I should be able to come here to head, and head points to some next one. And so I go get a temp variable here, temp. That's next node, okay? And then I do node.previous or node.next. So I get rid of this one and I put it to null, okay? Then I do previous. So that's this one. Oh wait, no, previous is going to equal the one that I'm currently at. So here is previous, okay? And then node, the one that I'm at right now, is going to be this next node, okay? So then I come back up and I say node.next. Well, that's okay, and then I say, so now it runs, and node.next is null. So next node is null, is previous. So now I take this one and I put it there, okay? and then previous equals node. Previous equals the current node that I'm at, okay? Node equals, then I say next node, which is null, and then we come up here and don't exit. Is that right? No. Okay. Just nothing. Okay, that's awesome. Okay, there we go. So what do we learn in this? It was something about like keeping track of where you leave off. I don't know. Pretty exhausted right now. Do we keep going or do I take a break and just, I kind of want to go for a walk. Leave Neetcode for a couple hours and then come back. I don't know, I don't feel like I did much in this video right now. Just failed at 2 problems and then take another break. Like that's not very good. Okay, whatever. Let's just do another one, I guess. I don't know. But which one do I want to do? I don't think I want to do any of those. Let's just try a heap. So, let's see, design a class to find the kth largest integer in a stream of values, including duplicates. For example, the second largest in here is 3. The stream is not necessarily sorted. Okay, constructor, initialize the object given integer k. Adds the integer value to the stream and returns the kth largest integer in the stream. obviously it's going to be some kind of heap, but heap q dot heapify and then nums, and then you can do heap q dot heap push, and then whatever, actually my heap, and then the value. So then you want my self dot my heap is equal to nums, and then you just want to put this in here. Self dot my heap, self dot my heap, like this. But if I pop k times, if I pop k times, then those elements are all gone. Okay, I don't know this one either. So you pop up there. If length of the min heap is greater than k, then I pop. Then I return the minimum value in the heap. Good. Okay, well, there's the answer, I guess. Alright, well, yeah, there's the answer. Okay, cool. Anyways, goodbye everyone. If you like the video, subscribe, and I'll see you guys later.